Okay, if we flip to the back side, we're changing it up, but still using our right trig, right angle trig. So you're still going to use SOHCAHTOA. However, since we're finding angles, that's going to be the key here, is you use the inverse trig functions to do all of these problems. So you still set them up using SOHCAHTOA, but since you're finding the angle, that's where you're using the inverse, the to the power of -1 key. So for instance, on the first one, here is the angle we want to find. We want to find theta, which is located here at angle A. So we got to label the two sides that we have. Across from the right angle is hypotenuse. Or next to the angle we want is adjacent. So we know that this trig function is cosine. So cosine of theta is equal to adjacent over hypotenuse, 6/9. Notice how we have both sides. My goal is to get theta by itself. So to get theta by itself, I take the cosine inverse of both sides. Doing the inverse undoes the cosine, so they cancel out. So I get theta to equal cosine inverse of 6/9. So in our calculators, to do the inverses, that's where you hit your second key and whichever trig function you want. Notice how when I hit cosine, the cosine inverse, or to the -1, comes up. And I type in the fraction 6/9, close my parentheses, and I get my answer, 48.189. Remember, we're going to round to the nearest tenth, so 48.2 degrees. Theta equals 48.2 degrees. Same process on all of these now, but again, we're just using those inverse trig functions. So on B, or the second one here, here's our theta, which is located by angle B. Across from it is the opposite. Next to it, which is not the hypotenuse, is our adjacent. So this tells me I'm using tangent. So tangent of theta is equal to 7.7 over 14. So again, I want to get a theta, or the angle by itself, go tan inverse on this. So theta equals tan inverse, in parentheses, 7.7 divided by 14. So calculator time, second tan, 7.7 divided by 14, close parentheses, 28.81 or 28.8. And again, these are degrees. I don't know if I put the degrees on the top one. Yes, I did. Just didn't circle it. So all of our answers here will be in degree measure. Number 3. So here's our theta. Take a look here. It looks like we got the adjacent, and we have across from the hypotenuse. So adjacent and hypotenuse here, we go back to a cosine. So we're going to go cosine of theta equals adjacent 4.4 divided by hypotenuse, which is 11. So cosine inverse, cosine inverse. So theta is equal to cosine inverse of 4.4 over 11. So use my calculator once again, type that in, second cosine, 4.4 divided by 11, and I get 66.4 degrees. So theta in this one is 66.4 degrees. All right. Next one, number 4 here. And we want to label where our angle is located and the size that we have. Here I have opposite. Next to I have adjacent. So we're back to tangent. So tangent of theta is equal to my opposite side, 11.9, over my adjacent side, 10. So Again, we're finding angle, so we take the inverse function, cancels out. Theta equals tan inverse 11.9 over 10. So calculator time, tan inverse 11.9 divided by 10. Go ahead and hit enter. 49.958. This is another one of those double rounders. The 5 causes this to become 0, or 10, which causes 49 to become 50. So theta ends up being 50.0 degrees. Again, like to put that 0 at the end to note that the answer has been rounded. Next one, continuing on here. So on this one here, here's my angle that I'm trying to find. Side next to it is adjacent. Side across from the right angle is your hypotenuse. So we're back to cosine. We've been jumping back and forth here from cosine and tangent here. So cosine of theta is equal to adjacent 4 over hypotenuse 5. Cosine inverse both sides. Oops, sorry, wrong place. There for a second. Cross out. So theta equals cosine inverse of 4 divided by 5. So theta equals second cosine 4 divided by 5, and voila, 36.9 degrees. All right, our last problem for this worksheet. So if we take a look at the sides we have, here is our angle measurement. So opposite is the 3 at the bottom. Adjacent is the 3 next to it. So on this one, we're going to go tangent, opposite over adjacent of theta, equals 3 over 3. If you said tangent of theta equals 1, completely fine with that. So tan inverse crosses out. Theta equals tan inverse 3 divided by 3. If you just want to enter in 1, that's fine by me. So calculator, so I go second tan of 1, and look at that, get 45 degrees on the button. So this one I don't have to put 0.0 because it's exactly 45 degrees. And some of you might have said, well, that should be the case. Right triangle, both sides are the same, so both angles should be the same. If this is 90, that leaves 90 left for those two, divided by 2. 90 divided by 2 is 45. All right, that ends this worksheet.